about percent composition of a compound. So just from name, what do you think it would mean, right? Percent composition. So in a compound, you have many elements that make up that compound. So when we talk about the percent, we're saying what portion of the mass of that compound is certain elements. Okay, so let's take, for example, water. Water has two hydrogens and one oxygen. But if you break it down to its mass, how much mass comes from hydrogen, whereas how much mass comes from oxygen? We can use percent composition to answer this question. And so it turns out that there is 11.19% hydrogen, whereas there are 88.79% oxygen. Okay. Now, just like any other percentages, all the individual components must add up to 100%, right? A whole piece. So 11.19 plus 88.79 is about 100%. Okay. Now, what this means is that wherever you take a sample of water, for example, if you have a small drop of water or a whole cup of water, if you take that sample, in either sample, the percent of hydrogen by mass will always be 11.119%, and the percent of oxygen by mass is always going to be 88.79%. So this is a useful number when we go to a technique called elemental analysis, wherein you take a sample and you analyze what is the mass percent of the individual atoms in that sample. And then from there, you can actually, if it's an unknown sample, you can determine what is the identity of that substance. So let's go back to percent compositions. There are two scenarios where you need to calculate this, right? The first one is when you have a chemical formula in front of you already, so you know based on the formula itself or from experimental data. So we'll go over these two scenarios one at a time. Okay, so the first way to calculate a percent composition is from the formula itself. So again, we will take the example of water since we have that going for us already. Like I said before, since it doesn't matter whether you take a drop of water or a glass of water or any size of water, water will have the same percent compositions of its individual elements. So to make it more convenient for us, why don't we imagine we have a mole of water? And we know that oxygen, for example, is 16.00 grams per mole. If you have 1 mole of water, how many grams of oxygen do you have? 16.00 grams, right? So to make this kind of easier for us, we're going to simplify the equation to calculate percent composition by simply stating, so the molar mass of the element divided by the molar mass of the compound, which is going to be a fraction for us because the bottom number is going to be large. It's the whole, whereas the top is a part, so it's going to be less than 1, right? So to make it a percent, what do? You multiply it by 100. Since we are assuming we have 1 mole of it, we can just get rid of the molar part and just say what's the mass of the element versus what's the mass of the compound from the periodic table. So in all of these, you want to figure out what is the total mass of your compound first. So let's figure that out. Again, we have 2 hydrogens and 1 oxygen. What is the mass of 1 hydrogen? 1.01 grams per mole, right? But again, we can abbreviate and make it easier for ourselves and just say 1.01 grams. Whereas oxygen, there is 16.00 grams. Again, so there's 2 hydrogens, so we have to multiply the mass by 2, giving us 2.02 grams. So the total mass is 16.00 plus 2.02. What is that equal to? That will be 18.02 grams. All right, so we have the total mass. So now let's calculate the percent composition of each element one at a time. All right, for hydrogen, what is the total mass of hydrogen in this molecule? Remember, each one is 1.01. You multiply that by 2 because there are 2 hydrogens. divided by the total mass of the compound, 18.02 grams, multiplied by 100. Get your calculator out. Gives me 11.21%. Now let's do that for oxygen. The mass of the oxygen is 16.00 grams, and there's only one, divided by the total compound mass, 18.02 grams, multiplied by 100, is 88.79%. So now let's add that up to see what is their total. Because I expect it to be around 100. Oh, perfect. It is exactly 100%. Awesome. And if you notice, I did say previously that the hydrogen percent is 11.19%. That's just from the textbook. And it doesn't matter because it's similar enough, it's close enough. There could have been some rounding errors that I did or that the textbook did, but the error is too small that it's insignificant and it would be okay. Okay, the second scenario is when you are going to calculate the percent composition of a compound based on experimental data. So this is more like in a real life situation. So for example, let's say you had a situation where zinc reacted with oxygen gas, which is O2, and you knew how much of it reacted. You knew that 1.63 grams of zinc reacted with 0.40 grams of oxygen gas to give you a compound that contains zinc and oxygen. Since we were given in this problem that that 1.63 is a total amount of zinc and 0.40 grams oxygen is a total amount of oxygen in this compound, we can take those numbers and find the percent composition of each of those elements. Okay, so let's do zinc first. Okay, so again, we have to take the part divided by the whole. The part here then is the zinc, which is 1.63 grams divided by the entire compound. Remember, the entire compound is zinc and oxygen, so we have to do an addition of those two first. So the total is 2.03 grams. So we're going to put that in the bottom. And again, we need to multiply that by 100 to get the percentage. So on our calculator, we can see that you should get 80.3%. I keep it to 3 sig figs since our numbers here had 3 sig figs. Great. Okay, now let's do it for oxygen. It's just straight up the mass that comes from oxygen. So that's 0.40 grams. You don't need to multiply by anything. Okay. Divided by, again, by the total mass of the compound. Multiply by 100. That would give us 19.7%. Now, do they add up to be 100? 100. Yay, that's pretty good.